Let's get this CPU built. So let's take all of the blocks that we've designed so far and we'll see how we're going to start building up this CPU. So we started off with a bus. Now I've only shown one wire here, but in effect there's going to be 8 wires in this bus because it's an 8-bit bus. But you'll see the entire 8 bits whenever we go and look at it in Logisim. So then we designed our little local storage registers. We've called these R1, R2, R3 and R4. So these are just our 8-bit registers. And we've seen that these have got a set and an enable. Whenever the set goes high, we're able to write from the bus into this little memory location. And whenever the enable goes high, we're able to read out of this memory location onto the bus. We then looked at the RAM. So we designed a 256-byte RAM, although we're only using 32 bytes at the moment. And again, it has got a set and an enable. So the set allows us to write information from the bus into a memory location, and the enable allows us to read the information from a memory location onto the bus. And we also have a memory address register, and this just gives us the address of the byte that we want to write and read to. We then went on and we designed an ALU. Now the ALU's got 2 inputs, an A and a B, and it's got its output here. It's also got 3 inputs here, which are called, we could call them opcodes. So this determines which function within the ALU we're going to use. We've also got our various outputs here as well, our carry in, carry out, our large equaling 0. Now we then went on and we looked at the clock, and we designed a clock, and we've seen here we need a clock pulse for the set and a clock pulse for the enable. Now there's a few extra blocks that we'll add in here, and we'll explain to them. I'll explain them just now to you. So first of all, we need something here we're going to call an accumulator. So what we want to be able to do is control all of the information that comes out of the ALU onto the bus. So we really want to control the timing of all the information out of this ALU onto this bus here. And we can do this here by an accumulator, which is just another register with a set and an enable. We also have this section here, we'll call it bus 1. Now you won't know what that's for until we start building the control unit, but all that does is put a value of 1 into this B input for the register. So that's 000001, so it's just a single value, 1 bit. Now you see that later what we're going to use that for. Now this here is a temporary register, and again it's similar to this register here, except it hasn't got an enable section. We only need a set. Now we have to have this in because we need to be able to read the 2 bytes of information onto the bus and into point A and B. So what we do is we can read out and into this temporary register, and we can set the value in the temporary register. Then we can go and we can get the other byte of information from one of the other registers or the memory, and it will go straight into point A. So it's a method of getting the 2 bytes onto A and B. So that's pretty much everything that we need for our CPU. But the question is, how do we control all these sets and enables, and also the opcodes here in this set point here, and also the input from the bus? Where does all this go to? And the answer to that is the control unit, and the control unit controls all of the timing for the sets and enables throughout the whole of the CPU. So this really is the beating heart of the CPU. So now we know all of the major blocks within our CPU. Let's go ahead and we'll see how they're built up within Logisim. So finally, this is our CPU built up in Logisim We've got the bus running around the outside, so that's the 8-bit bus. We've got our registers here are 1, 2, 3 and 4. Our RAM with our memory address register, our ALU, our clock, and we've got this accumulator, the bus 1 and the temp. So that's everything that we looked at just a minute ago. So let's have a wee look at this in a bit more detail. So one thing to notice is that in Logisim you can't have a single pin for an input and an output. They have to be separated into an output pin and an input pin. So that's what these pins are for. And you can see we've got the splitter here that splits it up into the 8 individual bits that go to the bus. So everything gets connected on to the bus. You can see this all the way around. So let's have a little look in the 3 extra sections. So first of all, we can look inside the accumulator sections. This is the accumulator section here. So if we zoom inside that, that is just simply a register. So it's the CPU reg underscore 8 which we've designed. So there's nothing new in that. Now if we have a look as well in the temp register here, again it's just the same as this type of register, but it's just a little bit simpler. So it's just simply the memory location, so it's just an 8-bit memory. Okay, so an 8-bit memory. So we've seen that before. Okay, and now if we go into finally the bus 1, and let's have a little look and see how this is going to work. So we said that this bus 1, what it did was whenever the input here went high, it put a value of 1 onto the bus here, and we're going to use that in the control section. So let's see it doing that just now. So whenever this is at 0, it just passes the information from here straight through to the output. Okay, so when the bus 1 is 0, this is just a straight pass through. But whenever the bus 1 goes high, it ignores the values here and just puts a value of 1 onto the bus. So how do we control the flow of information around this CPU and make it do something useful? Well, that's defined within the control section, and that's what we're going to go on to next. So thank you for listening to this video. I'll get you in the next video. Goodbye.